Hello, everyone. I am Alexander. Many of you know me. I'm program chair and one of the organizers of EuroPython. And I just want to give a short reminder. In 1 week's time is EuroPython in Rimini, and we're going to switch on-desk rates on Monday. So if you're thinking about going to EuroPython, buy your tickets this weekend. Otherwise, it will be more expensive. If you're a speaker or an attendee and have questions, come and ask me. If for anything, I'm here. But actually, I'm here to announce PyCon.de. That's a German Python conference. We are going to be in Karlsruhe this year. Karlsruhe is down here. Everybody knows this. It's well connected. We are the TGV to Paris and the ICE train to the rest of Germany. It's home of the KIT. That's one of the best universities in Germany, and it was for decades a major hub for engineering in Germany, probably the best engineering hub. And we're very happy to have the conference there. It will be at the Zentrum für Kultur und Medien in Karlsruhe. That's a mixture of museum and media institute. It has museums, exhibitions, and we're really happy that we can have the conference there. It's the location Kraftwerk actually chose 1997 for the opening to have their first concert, I think in more than 10, 15 years in Germany. So here are all the facts. The conference is end of October. The CFP is open, and we will be very data heavy in Karlsruhe. And one way, Catherine is also one of the organizers. So you know, everybody knows Catherine. Yeah, just in time. Thank you. Yeah. The CFP is open. It will be quite data heavy since we're in a tech hub city, so we will have many PyData talks there. We're also happy if you want to submit a talk. Early birds tickets are still available, so we're going to switch soon. And you can find more information on our website, or you can ask me at a social event, and yeah, that's it. Thank you.
Question? We have time for that.
Yeah. Has anybody a quick question? One quick question. What you always want?
Fine.
Super.
Next speaker.
How awesome will it be? Really awesome.
Yes. That adapter. Do you want this or that?
This will be fine. All right. Fingers crossed. Did something.
Looks good.
Awesome. Hi, everyone. My name is Stefan, and I'm here today to warn you of a troubling development in Python. Python is turning into Java. So as we all know, Python is the greatest language in the world, and we're very used to the fact that other languages learn from us. We're great, and even Go, which has been getting a bit more attention lately, is really just a compiled Python. And don't even get me started about JavaScript. JavaScript is imitating Python so much that it's getting a bit awkward. Generators, for example. JavaScript took them, made them a bit worse by requiring that little asterisk on the function keyword, but still they're our idea. So you're welcome, ECMAScript. Whitespace indentation. You're welcome, CoffeeScript, I guess. Okay, whitespace indentation is a bit more of a disputed issue, but still Python is great. So let me highlight some of the recent things that have been making their way into Python 3. What on earth is this? So we've got an enum there. We used to be fine without enums. Do we really need enums? Then there's something about a single dispatch, you know, that calls the same function depending on the type of the argument. And then finally, is that a type annotation I see in that function signature? That smells like coffee to me. So let's deconstruct everything that's wrong with this piece of code bit by bit. And I hope you noticed the sarcasm tag in the beginning. Enums. I mean, what was wrong with just passing strings around and testing for string equality, or at least, you know, making module-level variables and counting up 1, 2, 3, 4, 5 manually? That worked fine. Enums, well, if you're honest, they're a little bit nicer. You can actually list all the things that are in an enumeration, and somehow that first kind of thing in the enum is 1, but also it's smart enough to know that it's not 1, it's a different thing. So, okay, maybe enums are a little bit smarter than just, counting, passing names for integers around. But I think we all agree that Python loves dictionaries, and you should put all your data in dictionaries, right? I mean, classes are dictionaries, objects are dictionaries, and much of the Python standard library actually operates on dictionaries or mapping types in general, argument parser, config parser. So if you've got a little function here that just summarizes a hotel, you should just put your data in a dictionary. And, well, actually, one thing, though, is that there's a typo in that code. It says print hotel reviews conut, which I'm sure you noticed. And also, what else is in hotel anyways? It's a dictionary. What is in there? Well, that's easy. You just add a debugger step and look inside. Surely, Python would never look like this, because that's ugly and looks like Java. Actually, some of you might know that this is actually valid Python 3.6 syntax. And even though it's totally unnecessary, once you actually start using it, it does turn out to be nice. So this is a screenshot from my PyCharm. I have that class up there. I'm annotating my hotel parameter to be of that type. PyCharm notices that reviews conut is actually not a member of that class, and even though I'm in one of those new Python 3.6 format strings, there's autocomplete that tells me, hey, there's a score, that's probably what you want to print. All right, this actually isn't all that bad, but single dispatch, is that really necessary? So single dispatch made it into this Python standard library in 3.4 or something, and it's about calling generic functions depending on the type of the first argument. Again, this smells so much like coffee, and what you can see here is that there's a generic function up there that's kind of a fallback, and then if you want a different version of the same function to be called depending on the type of the first thing, and here I'm referring to the things enum from before, you can do that. And notice down there I'm calling handle things kind of thing. I'm not calling handle things. Python just calls that thing. So I'm doing stuff depending on the type. Weren't we doing duck typing before? What is wrong with this picture? This has been working for years, right? Actually, so duck typing is evolving in the Python language a little bit, and instead of, just believing everything that quacks, you actually believe the duck, that it tells you to be a duck. It's still duck typing in a way, but this is where the sarcasm ends. I really like all these new features that Python 3 recent versions are adding. In a way, Python 3 is growing up together with us. These features are optional, but they're very useful for code that is read more often than written, and that's most code really, and large projects. So you should all use the latest Python 3. Thank you.
No? Just a minute. Let's just how do I get out of it? Okay, good. So we are at a conference, and maybe you like conferences, maybe you like another conference. Therefore, I would like to talk about EuroSciPy. EuroSciPy has an anniversary this year, so we have a 10th edition of our European conference on Python in science. It will be in Erlangen, Germany. It's just a few hundred kilometers south of here, so you can take a train to Erlangen at the university. And it will be soon. It will be the end of August, so still in summer. So we have about less than a week of conference. EuroSciPy is a bit different than PyData. It's a general Python conference, and it's very cross-disciplinarity. So a lot of people from different backgrounds in science, starting from agriculture to zoology, are there, and they present their research. The call of contributions is extended till tomorrow, so if you would like to present a talk, a poster, or a tutorial at this conference, you need to hurry up because you only have time till tomorrow to submit. Registration is also open. A few important dates. So the extended deadline for the talks is tomorrow. And the early bird registration is still open for a while. And then we have 2 days of tutorials. That's very nice, very interesting, because half of the conference essentially is tutorials. The other half of 2 days is talks, and then we have sprints. So if you would like to sprint on some scientific Python project like NumPy or SciPy or something, Pandas or other projects, then you can take part in a sprint or organize your own sprint. The prices are pretty reasonable. If you see here, this is the prices for the tutorials. So the early bird is still valid. Also, and the same prices are available for the conference, so you can either register for either one or for both of them. So if you're interested in Python and science, you shouldn't miss the opportunity to come to EuroSciPy in Erlangen in less than 2 months. Thank you very much.
Our favorite download. I love this, that when you work with it, with Scikit-learn, you download breast cancer. I don't know how you feel about this, but it is useful to have the data included in the package.
Yeah, thank you for that brief introduction. I'm Jonas Steuren, and I will talk about screening breast cancer with Python. If at any point in the talk it isn't really clear what it has to do with Python, well, just be patient. Things will get clearer near the end. So first, some context. In the Dutch context, we have a screening program for breast cancer, and all ladies between 50 and 75 are voluntarily coming for 2 years to have a screening mammogram. So it's really successful. It saves about 850 lives per year. And participation halves the risk of dying from breast cancer. But there are some challenges there is that in a screening setting, most images are negative. There are lots of images to, there's a really high screening volume, so radiologists have little time to screen each image. So this creates lots of opportunities for machine learning. Well, first of all, this is a mammogram, well, a machine. So you compress the breast, so you have a low radiation dose. Apparently, it's really painful, so you want to do this as quick as possible. But of course, we want to do this with a computer. And here I just took an image of DCIS with ductal carcinoma in situ. And the signs of this type of cancer are all kinds of are these small dots. You also have just normal tumors, which are really large masses in the image. And right now, how we do this with machine learning is, so basically we start with a screening mammogram, which is an X-ray image. We have a candidate feature extraction that extracts the candidates, and then we use a random forest classifier on these candidates. This is the classical way to do it. And well, on the left image, the first stage in the pipeline creates lots of candidate regions, which are then classified using neural network. And as you can see in the next image, right now we're almost doing as well as a radiologist. So in the end, if we would be able to use this, if we use a system in a screening setting, we could filter out many of the negatives and reduce the amount of images a radiologist has to screen. We have many other, so as I said in one of the previous slides, in DCIS you want to detect the small dots, and these are called calcifications. And at least our recent models with neural networks outperform the classical models, which have been developed for the last 20 years, and this is from 2016. One more thing, and if you like medical imaging and you would like to work in deep learning on medical imaging, please check out our vacancies. We have a lot of postdoc and PhD positions available.
Thank you very much. Now we'll hear about how to win a Nobel Prize in Literature with Nobel training. Thank you. Sorry, we're not quite ready yet. Is the next person? Yeah, hi. So we'll hear about deep learning.
Okay, so my name is Sachin, and I've been working on a few tutorials on deep learning at my company. So the aim was to get people up and running on deep learning as fast as possible and make it practical, right? And just keep in mind that these people, they have a very minimum experience in machine learning. So I want to get them started on doing even the advanced models as fast as they can. So if you could, just go to this link and just check it out to begin with. So it's mainly a GitHub page right now. So what I wanted to do is imitate something like Node School. By the way, I still haven't registered this name. It's available, so please don't register it. Right. So moving on. So like I said, the aim was to make it easier, minimize the required amount of mathematics that you need, because especially these days, you don't need that much mathematics to get started on deep learning. It's only a few lines. Make it practical so that you can run it on laptops, right? Yes, GPUs can come later on. The whole point, again, is to get them up and running so that they can do it later on. And open sources. So I do want you to, if you could, contribute to this these set of tutorials so that yeah, it could get better. So what I have is these bunch of lessons. So far, I've only got 12 lessons, but just to give you a taste of what I have. So I'm mainly using Keras to do this, right? So over here, you can see this. It's only, what, 5 or 6 lines of code to get a deep neural net running. And I think in this case, it was a sentiment analysis problem, but the main point is you only need a few lines of code to do deep learning these days. I've gone on to do, so the latest thing that I've done so far is convolutional nets. One thing that's really missing, I guess, is there's not enough text, I suppose. So what I tend to do is there's generally a YouTube link in most of these tutorials, not that one, but okay. Anyway, so some of the tutorials have a YouTube video at the top, and I try to make sure that these are the takeaways, and I try to document that. Okay, like by the end of this tutorial, you should know these terms. So just quickly going through a convolutional net. That's a convolution, but as far as the code goes, which is really what I'm trying to get across, again, is 5 or 6 lines of code. Just quickly running down to this one. This was a CFAR10 data set, so we have there's 10 classes that I had to classify, and there's 10,000 images for this, and it ran in less than 10 minutes, and the accuracy was about 50%. Now that's not that great, but considering it's 10 classes, that's actually pretty decent for 10 minutes of training. So just running down to the bottom. Okay, so these are some classes that are predicted. So it classified bird fairly correctly, horse is fine. Now when it came to dog, it classified as a cat. Now I don't know if a Chihuahua classifies as a dog, but you know, yeah, that's a different question, I guess. Yeah, so anyway, the point of this talk is if you can contribute to this GitHub repo, I probably need a bit more help in the documentation more than anything, because I've really focused maybe a bit too much on the code rather than actual text, writing stuff in, because I do generally do a YouTube video with this, which I've attached to most of the tutorials, but not everyone. So yeah, so that's pretty much it. So yeah, if you have any questions, come talk to me afterwards. Thank you.
Well, like lightning questions only. Yes. 30 seconds.
Yep.
So can somebody buy the domain? Are you going to pay for it? Or are you going to
So, sorry, I missed that. Oh. Don't ransom it, right? So.
Okay, thank you very much. We're going to have someone talking about distributed representations of medical concepts. Yes.
Hello, everyone. So this is going to seem like a shameless plug compared to all the lightning talks that we've seen so far, but I want to talk to you about some of the work that I'm doing at Babylon Health, which is a healthcare company based in London. I'm a part of the machine learning and NLP team there, and I'll talk to you about distributed representations of medical concepts. So surely you've heard of Word2Vec today at least 5 times. But I'll take the liberty to take you back to the basics of what it is and why we're using it. So essentially, we're using it because it's a better universal representation of words, better than what we had before, something that we handcrafted ourselves. And we can plug it very easily and in different machine learning models across different platforms, and it's much more universal than what we had before. So why do we really care about this in Babylon? Our current dispatcher model, the thing that talks to the patients and decides what to do with them, is based on a deep learning model that uses text embeddings. But this is a fairly simple task. We want to do more complicated things, and we want to extract things. We want to be more flexible in matching in our information extraction tasks. So we need something better than that. So let's start from the basics, from real basics. So you should know a word by the company it keeps. That's what John Firth said, basically paraphrasing Rousseau and Wittgenstein. And you can see it. Everybody in the room probably knows what the word is missing, right? If you don't, maybe you shouldn't be at this conference. So if we can tell the word by its context, then we can compare context to define similarity between words. And if we can do that, then maybe we can build models for each of the word, and then for each word, and then compare those instead of comparing context or comparing words. And that's what word2vec does. It takes, it builds a dummy task which guesses if the word fox is there or not, if it based on the context, and then builds a model, and the model is essentially the word fox in our new model space. So essentially, this model is a very ugly vector of floats. Okay. Sorry about that. Which we can represent nicely in the two dimensions that sort of look like this. This is generated based on Google News's corpus. And this is sort of useful, but one more useful thing that we are interested in is the compositionality property of the vectors. We can do certain operations with these vectors which result into something. I don't know, how many people are aware of what this is? Okay, so basically, so not everybody, so basically we are able to take the meaning of, to take the vector for king, subtract the vector for his gender, so subtract man, and essentially get a vector for a genderless royal, and then add another gender, woman, and get the vector for queen. And why is this useful? This proves that we can manipulate vectors and the results are actually meaningful. They're not just random things. There is a space that operates, and there are maybe not all the operations that we can think of work, but some of them do. So, shall we know a disease by the company it keeps, is the question that we are pondering at Babylon. And the answer is yes, but not the company of words. So the reason for that is we want to encode medical knowledge, not meaning. So not everything in medicine is expressed in text, and you can't just infer all of the medicine from all the text that exists. Even if you take all the text, there's just not, some things are not encoded in distribution. So what we did is we turned to a medical ontology, and which is basically a very, very big graph with a lot of connections in it. And we generated a lot of random walks, which are kind of like sentences when you think about it. They're sentences of medical concepts. And, sorry.
Okay, you have 30 seconds.
Well, that's actually the last slide, maybe. So the result is a similar space, and you can do similar operations with vectors, which kind of work. We don't know what we're going to do with that yet. We are still to figure out how to test it, how good it is. So thank you, and never mind Brexit, we're hiring.
Much. Thank you. Next, we'll have gesture recognition with deep learning.
Hi. So just give us 30 seconds to set up. So first things first, we've decided to provoke the demo gods today. So we're going to show you a demo of our real-time gesture recognition system. We have absolutely no idea whether it's going to work on this stage, in these lighting conditions, and so on. All right. So the first hurdle, connecting the laptop to the beamer, has worked. All right, so my name is Valentin Henel, and this is Joanna Materzinska. And we're employees at 20 Billion Neurons, one of the sponsors, the lanyard sponsor of this conference. And over the last couple of months, we've built a gesture recognition system using deep learning that works in real time. Basically, what you can see here is a simple screen and a bunch of classes. So I'm not sure how well you can read them. But some of these classes are, for example, stop sign. So maybe you could do the stop sign. Ooh, demo god's not in our favor. So as you can see, building any kind of deep learning system that is invariant is a difficult task. Maybe you can continue to do other things. All right, we'll fiddle with it a little bit more. I'll tell you a few details about this system. So basically, we crowd-acted about 120,000 videos on Amazon Mechanical Turk of basically people just sitting in front of their webcam and performing certain kinds of gestures that we predefined. So in total, it was, I think, 27 gestures that we predefined. And yeah, basically, we got lots and lots of people all across the globe of various different nationalities, genders, skin colors, and so on and so forth to essentially record these videos. We then trained a deep learning model using a whole load of 3D convolutions, so it's actually quite expensive to really capture the temporal aspects of the videos. What should we do?
I don't know.
You want to try it in front of the white wall?
Yeah.
Could one of you hold the laptop, potentially? So it does actually work. I promise you, it does work. Yeah, it keeps, so that's drumming fingers. Let's see what it says about the room. So there you go. So that's it. Yeah, that's the end of our presentation. We're going to be around. We're probably going to get a desk somewhere, maybe later on, or maybe tomorrow. And then we'll try it again. And yes, we are certain that it worked. And in fact, a couple of weeks ago, our CTO did a demonstration, and it just worked perfectly. I'm very surprised why it's not working today. Thank you very much.
Now we'll have Catherine, who will tell us about how to win the Nobel Prize. And you can start speaking in 5 minutes. In 5 minutes or less. You can start speaking. I'll turn this on.
Thank you.
No? You can speak into this. No? Go ahead. No?
No,
Good evening. My name is Cătălin. I'm from Romania, and I'm working at Autoliv. I'm doing machine learning, but I will not speak this evening about the self-driving car, but more about myself. And the 1 minute introduction story starts from when I was a little child, and I heard something about Nobel Prizes in literature and the fact that there are some big things, and I said to myself, okay, I want to get one. After that, I completely forgot about wanted to win a Nobel Prize in literature, because I wanted to become an astronaut, then a scuba diver, then an archaeologist, and many, many others. And I remember about these sort of things only recently, when Bob Dylan won the Nobel Prize in literature. And I said, okay, so probably I missed the first thing in winning a Nobel Prize, which is writing literature. And okay, so
the Nobelizer?
yes.
Keep talking.
Okay, so since I lost the start, I downloaded all Bob Dylan's lyrics, and I trained a recurrent neural network, an LSTM type of neural network, actually. So it's a sequence-to-sequence type of network. It maps a sequence of a given length of characters on the shifted sequence with one more character. And like this, it's able to predict character by character the next one. And I started with an embedding layer. I've done this in Keras. I will show you bits of the code in the last minute, probably. And then 2 LSTM layers, one feeding into another. But some of the results, if we can scroll down a little. Oh. Some of the lyrics are so that I think about a highway. I was high where my heart is ready, and like that are well, reasonably poetic. And I have also experimented a hybrid person between Bob Dylan and Marilyn Manson. And so I forgot to mention that, so I gave, for the prediction part, I gave the string knock, knock, knocking on heaven's door, and let the algorithm continue, let character by character. And the hybrid is, yeah, again, pretty poetic. So knock, knock, knocking on heavens, looking for pain. And well, yeah, so probably I'm more or less out of time, but if you go to GitHub, and yeah, you can see the network itself is kind of Jeremy Howard style of LSTM networks. So yeah, that's it. Thank you.